Okay, so if you're working on the worksheet practice conditionals and biconditionals, we're going to go through the problems that have asterisks next to them. And the first one is number 1. And it says to identify the converse, inverse, and contrapositive of the original statement. So your original statement, your original conditional, is always going to be labeled P for hypothesis, then Q for conclusion. So two segments being congruent is your hypothesis. Having the same measure is your conclusion. Okay, so let's see how each of these, A, B, and C, have changed and identify if it's converse, inverse, and contrapositive. All right, example A. If two segments aren't congruent. So two segments aren't congruent. Well, here we talk about two segments that are congruent. So not being congruent is going to be the opposite of our P. Then this should be a Y, they don't have the same measure. Well, we said Q was that they do have the same measure. Now we're saying they don't have the same measure, so it's going to be the opposite of Q. So if you recall, opposite of P, then opposite of Q, or inserting a not, or the opposite of in is out, we are talking about the inverse. Okay, the next one, two segments have the same measure. If two segments have the same measure, well, right here, they, referring to the two segments having the same measure, is dealing with our Q. They are congruent. They being the two segments are congruent. Two segments that are congruent is dealing with our P, is our hypothesis now. And remember what I said, just because it says two segments doesn't mean that our hypothesis of two segments is our hypothesis. The thought of them being congruent is our hypothesis, not the two segments. So we can say, instead of saying they here, we're allowed to say two segments. So don't just look for the two segments and say, oh, that's P. Two segments is the subject. The idea is your P or your Q. So the idea of being congruent is your P, which is over here. They are congruent. All right, that being said, we have flipped our original conditional. Instead of P then Q, we have Q then P. And how do we do flips? Remember, you can do a flip in your Converse shoes. So that's going to be the converse. All right, and then the last example, C. If two segments don't have the same measure, well, here we go again. They having the same measure, they refers to the two segments have the same measure. That was our Q. But now we're saying they, the two segments, don't have the same measure. So now we're taking the opposite of our Q. Then they aren't congruent. Well, here, they, meaning the two segments, are congruent. That was our P. But we're saying they aren't congruent. So that's the opposite of our P. So what we've done here is we have flipped our original conditional. It now is Q then P. And we have negated it. So we've done a whole bunch of stuff. That means our definition must be a whole bunch of letters. So it's going to be the contrapositive of the original statement. Okay, so you should be able to finish the number 2 and 3 on your worksheet. Let's go to number 4, example A. So we're going back to our symbols, using the given P and Q, write the symbolic statement in words. So this is the P, the sky is sunny, and the Q is that it is not raining. So here, example A, we want to know the opposite of our P. So here's our P, the sky is sunny, and now we want to write the opposite of our P. So the opposite of being sunny, you can say the sky is cloudy, or you can say the sky is not sunny. Just remember, the opposite doesn't necessarily mean not. You can actually talk about the opposite of sunny being cloudy. Okay, so we're just going to do example A, but I do want to look at letter C, I guess. When you see this arrow, that is telling you that it is a conditional, which means that it is an if-then statement. So this tells you that you are writing an if-then statement. Here we were just writing the opposite of P. The sky is cloudy. There was no arrows. We just had to take P and make it the opposite. Here we need to put these two phrases together, Q and P, but make it a conditional statement. Okay, the next example is number 5. We're going to write the inverse, converse, and contrapositive of the statement. I've only ostracized the inverse and the symbolic statement. So the rest of it, converse and contrapositive, is all on you. Alright, so let's look at the inverse of this statement. The conditional says, if a thought boo can make a poot show, then all go groups are purple. That makes absolutely no sense. But don't worry about the logic involved in this statement, or the sensibility involved in the statement. Let's just worry about the semantics of our hypothesis and our conclusion and how we perform the inverse of that conditional. So, a thought boo can make a poot show. That's our hypothesis. So anything dealing with a thought boo, make it a poot show. Then all go groups are purple. That's your conclusion, your cue. So if we were to write this symbolically, we always start with our original conditional being if P, then Q. Okay, so the inverse, remember the definition for inverse. The opposite of in is out, or insert a not, insert a negative. So just remember the definition. I know I'm telling you the definition, but this is something that you've got to be able to recall without your notes. All right, so let's take the inverse of the statement. So if a thought boo can make a poot show. Now, I don't know the opposite of a poot show, so I'm just going to say cannot make a poot show. A thought boo cannot make a poot show. Then all go groups are not purple. So instead of doing the opposite, we are just going to insert a not here. So my final conditional was, or the inverse of the conditional was, if a thought boo can't make a poot show, then all go groups are not purple. All right, symbolically, remember we still have the same order of our hypothesis and our conclusion. So it's still an if-then, hypothesis first, conclusion last, but we have taken the opposite. Remember the tilde here, the opposite of our hypothesis, and now the opposite of our conclusion. So when you take your little exit quiz, you're going to have to be able to identify inverse, converse, contrapositive, but you're also going to have to identify it symbolically. Okay, and the last example on the worksheet that we're going to go over is number 6. Given the two true conditionals, write an if and only if statement. This is very important to remember. The only time we can have a biconditional or an if and only if statement is when the conditional and the converse are both true. So in this case, I'm telling you that they're both true. And now you can write an if and only if statement. But if I don't tell you they're true, and I say, hey, can you write an if and only if statement for this? Or can you write a biconditional for this? If the converse isn't true, then no, you cannot write a biconditional. So just remember that, because that will come up in later quizzes and such. Okay, so here's our conditional. If a triangle is obtuse, then it contains an obtuse angle. The converse, if a triangle contains an obtuse angle, then the triangle is obtuse. In our if and only if statement, remember, we just join our original hypothesis here and our original conclusion here with the words if and only if. So, of course, take out this here. I told you we don't have the if in there. A triangle is obtuse if and only if it contains an obtuse angle. So that would be your if and only if statement. So when you write out your solution to this, if you write IFF in big capital letters, that is implied if and only if. You can write out the if and only if. That's completely up to you. But I do want to just touch real quickly on the symbols of a biconditional statement. Remember, if you have an if and only if or a biconditional, you've got this double arrow. And the reason it's a double arrow is because you can read this backwards and forwards and it's still true. A triangle containing an obtuse angle is obtuse. So that's reading it Q then P. And then P then Q is our original triangle is obtuse if it contains an obtuse angle. So this double arrow here just implies that our original is true and our converse is true. So it's true both forwards and backwards. All right, so go ahead and finish up the rest of this worksheet. You should be able to do it on your own now, but come on up and get it checked when you're done. Take your little exit quiz and move on to the next lesson, hopefully.